This is Aotearoa, New Zealand's South Island from space. A winter blizzard has covered the mountains with snow. And the straight edge that you see along the Southern Alps is the longest natural straight line on Earth. This slice through the landscape is the Alpine Fault, a geological masterpiece and a ticking time bomb. Look closely here. A uniquely recognizable rock formation called ophiolite has been pulled apart along the fault by an incredible 480 kilometers. That's how far the Alpine Fault has shifted over millions of years since its first rupture. Fast moving by global fault standards, the Alpine Fault has been shaping the landscape for millions of years. But for all this dramatic activity, one burning question haunted scientists. Does the fault move slowly over time, or in sudden catastrophic earthquakes? In 1964, a simple experiment provided the answer. Scientists built a wall right on top of the fault. If the fault moved slowly, the wall would shift or crack over time. But 6 decades later, that wall remains intact, telling us that the Alpine Fault moves suddenly in devastating earthquakes. The most recent of these quakes, a massive magnitude 8.1 in the year 1717 that caused landslides that wiped out huge areas of forest. To find out more, scientists have spent decades investigating the fault by drilling into it, cutting through it, and hunting for clues of its history in this wild and unforgiving landscape. Fast forward to 2012, a groundbreaking discovery at the fault's southern end. Scientists found that earthquakes here happen with startling regularity, roughly every 300 years for the past 8,000 years. This degree of regularity is unique in the world. So with the last earthquake now over 300 years ago, how near are we to the next massive quake? A team of scientists worked on a new project to core deep into the lakes along the fault, searching for earthquake layers buried in the sediment.
Oh, beautiful.
The result, a consistent record of powerful earthquakes, often ripping the fault from one end to the other. And with it a new realization. The probability of a major earthquake in the next 50 years is an alarming 75%, and it is highly likely to be at least a magnitude 8. When, not if, the next big one hits, it will trigger landslides, shatter infrastructure, and could isolate whole communities for months. Understanding and preparing for events like this is why we need Earth scientists, people who dedicate their careers to studying natural hazards like earthquakes, volcanic eruptions, landslides, tsunamis and storms. These experts help protect our communities and guide us through these inevitable events. That's why I'm excited to tell you that this video is sponsored by Te Herenga Waka, Victoria University of Wellington, New Zealand. Their scientists are at the forefront of researching geological hazards, finding solutions that could one day save lives. If you are passionate about the Earth and want to be part of the solution to the world's biggest challenges, whether it's natural disasters, climate change, green energy or large-scale engineering projects, the world needs earth and environmental scientists like never before. I personally know many of the incredible staff at Victoria University's School of Geography, Environment and Earth Science, and I wholeheartedly endorse their courses. If you're interested in a career in earth science, think about joining the next generation of geoscientists at Victoria University of Wellington, New Zealand. Check out the link in the description for more information. The future is waiting. What role will you play in creating it?